Hey everyone, in today's video we're going to be talking about a question in which we're given the equation of a line and we have to write two equations of different lines. One that's going to be parallel and one that's going to be perpendicular. But that's not all. We're also going to have to make sure that those lines go through a specific point. So let's go ahead and let's get started. Here we have the question. It says write the equations for the lines that are parallel and perpendicular to the given line J that passes through Q. So here we have the equation to the line y equals negative 4x plus 1, and we have this point Q, 6 comma negative 1. So let's go ahead and let's first understand what they're asking us to do by looking at sort of a visual representation of this line and this point. Here I have graphed the actual line J and point Q. What they would like us to do for this problem is they want us to write the equations of two new lines. One that's going to be parallel to this red line, but also goes through this point Q. So we need to find a line that sort of looks like this. It's going to be parallel and goes through this point. Sorry, I did not draw the best straight line. Let me try that again. Parallel and goes through point Q. So something like this. Then we're going to have to also draw the equation of a line that is perpendicular but also passes through point Q. So that would be something like this. Or actually, better yet, something like that. That goes through the red line perpendicularly but also goes through point Q. So this is what we're trying to do. One equation that's parallel and goes through point Q, and another equation of a line that's perpendicular to the red line and goes through point Q as well. So let's go ahead and let's start off by talking how we can do this. Well, to find a line that's parallel to this one, we know that parallel lines have to have the same slope. So I noticed right away that this equation is written in slope-intercept form. Y equals mx plus b, which is a concept that hopefully you learned when you took algebra, but really, we use this form because it's very easy to get certain information from it, mainly the slope in this case. The slope is what's in front of x, so I know that by looking at this equation that my slope for this line is in fact negative 4. So I know that in order for a line to be parallel, let's go ahead and first we're going to do our parallel line. Because the slope of this equation is negative 4, I know that my slope for the new line has to be negative 4. I also know that it has to go through this point Q, which is 6 comma negative 1. So what we do is we take this information and we plug it into the slope-intercept form. And it's going to help us find this point B. So here I have m. M in this case is negative 4. My x value would actually be 6. And my y value would be negative 1. We have an x and y point that we can plug into the slope-intercept form that would help us find b. So I would have negative 1, because that's what y equals negative 4, which is m, multiplied by, 6, because that's what x is, plus b. And now I can do some multiplication here. Negative 4 times 6, that would be negative 24 plus b. I can add 24 to both sides. I get b equals 23. So now I know my slope and I know what the y-intercept needs to be. That'll ensure that this point goes through 6 comma negative 1, that this line goes through that point. So my equation for this line that's parallel would in fact be y equals negative 4x plus 23. And that is me following the slope-intercept form of y equals mx plus b. So here's the equation to my parallel line. This is the parallel. Now I got to think about how can I graph, or how can I write the equation to the perpendicular line. So let's go ahead and let's move down a bit so that we have more room to write. Now we want to know, what about the perpendicular line? Well, again, we use the idea. We know that the slope to the line that they gave us is -4. What we have to do is, for perpendicular lines, slopes are actually reciprocals, negative reciprocals of each other. Okay, so what we do is we know that the product of each of the slopes for perpendicular lines, if we get two lines, multiply their slopes, we should get -1. In order to make sure this happens, what we do to the slope that we're given, the slope of the given line was -4. We have to take the negative reciprocal of that slope in order to get the slope to our perpendicular line. So this means that we have to do two things. We have to sort of reverse it, flip it. It's a fraction and we have to flip it and make it the opposite sign. So in order to flip it, sometimes right now I know that might not make sense because it's a whole number, but we got to remember that whole numbers are actually, we can make it into a fraction by putting it over 1. So the first thing into finding the slope of a perpendicular line, so what would be the slope of a line that's perpendicular to this one? Well, what I have to do first is I have to flip it. Let's flip it. And I get 1/4. The next thing we would do is change signs. So instead of it being negative, now it's going to turn into a positive. And this is how we find the slope of a perpendicular line. I know that the line that's going to be perpendicular to the one that they gave me here has to have the slope of a positive 1/4. And we can prove that these two slopes would be perpendicular to each other. We can multiply them. I can do 1/4 times -4 and I get -1, which we know that has to be true for perpendicular lines. So once we find our slope, I now know that my slope has to be 1/4. And I also still know it has to go through this point, 6, -1. And we do the same thing we just did here, where we're going to plug it into the slope-intercept form equation, y equals mx plus b, in order to find what's the b value, what's my y-intercept to this line. So I'm going to have y equals mx plus b, where again we have m, we have x, and we have y. So I'm going to have -1 equals m, which we just found was 1/4, by taking what we call, again, this is the negative reciprocal. And we're going to multiply this 1/4 by x, which is 6, and plus b. Now we can go ahead and multiply. We get -1 is equal to, if you multiply this together, you get 3/2 plus b. We can subtract from each side the 3/2. -1 minus 3/2, if you do that correctly, you get -5/2 equals b. So we now know that b equals a -5/2. You could have also turned this into decimals, Negative 3/2 is the same as negative 1.5. You could have subtracted 1.5 from each other. That would have also gotten you negative 2.5, which is the same as negative 5/2. But now we have all the information that we need to write this perpendicular line. We have our b value and we have our slope value. So now we plug it in again into slope-intercept form, and we get y equals 1/4 x minus 5/2. And this would be the line that's perpendicular. Okay? And what we're actually going to do now is we're actually going to graph these on a website known as desmos.com, and we're going to make sure that what we just did is in fact correct. So here you can see the equations typed up on the left hand side. Y equals negative 4x plus 1. That was the equation that they gave us. I'm using the website desmos.com. It's a graphing calculator that's free. It's a great tool. I highly recommend it. Here we have the point plotted 6, negative 1 as well. That's Q. We can see it here on the graph. And then in green is our line that's parallel. That's the equation that we came up with, negative 4x plus 23. And as you can see, it's parallel to the red line and it's going through point Q. So we satisfied that mark. This shows me that that equation was in fact correct. And here in the purple, we have our perpendicular line that definitely looks perpendicular. We know for a fact it is because we multiplied those slopes. We started with a perpendicular slope. But the question was, what does that y-intercept need to be? Well, when we plugged it back in, we got negative 5/2, which gave us the equation y equals 1/4 x minus 5/2. And here you can see that it does in fact go through point Q, and we know that it's also perpendicular. So we did it. So hopefully now you feel like you can write the equation of a line that's parallel or perpendicular to any given equation. Okay, again, it all has to start with finding out which slope do we need to use. If you're working with parallel lines, use the exact same slope that they give you when they give you an equation. If we're working with perpendicular lines, we have to take the slope that they give us and write the negative reciprocal of that slope. Okay, then to find b, we plug in the point they give us that they want us the line to go through, and we use the slope depending on whether it's parallel or perpendicular. We plug all that in and we solve for v. Okay, and then we can get any equation that we want. As always, I just want to thank you for watching. You might feel like you need to rewatch this video, and that's totally okay. Go back, pause, rewind, and keep watching over the same 5-10 seconds as many times as you need to in order for it to actually stick and you say, okay, I'm comfortable, let's see what he did next. Okay? As always, I hope that you continue to learn through these videos, and I just want to thank you for watching.